Good afternoon, students. Last time we studied about electric current, charges, potential difference. Today we are going to study further. Last time I showed you simple electric circuit. You can see this is a diagram of simple electric circuit. This is the battery, this is the switch, ammeter and bulb. In simple electric circuit, bulb and ammeter are always connected in series. Series means side by side. Today let us study about circuit diagram. What is meant by circuit diagram? It is a schematic diagram of closed path of current through different electrical components using symbols is called circuit diagram. Electrical components means the bulb, the ammeter, the key and the battery are called as the electrical components. You can see here the electrical components are designed in such a way that when current passes through it, it will pass through the conducting wire. And we can't draw the bulb, battery as it is. So symbols are used, symbolic representation. So this is symbol of bulb, ammeter. Connection of this in this way, it is called as circuit diagram. Always remember, in simple electric circuit, the charges flows in left to right, then the current will flow from right to left. The direction of current and direction of the charges in an electric circuit is always opposite to each other. In a simple electric circuit, the current will always flow from positive terminal to the negative terminal. I already told that in circuit diagram, we are going to represent the components with certain symbols. Now I am going to explain which components are represented by which symbol. We want to represent a cell. The symbol for cell is a big line and a small line beside it, and it is connected with conducting wire. The big line represents the positive and the small line represents the negative. This is the symbol used for cell in circuit diagram. Battery. What is meant by battery? When two or more cells combine with each other is called as battery. So let us show the symbol of battery. One big line, one small line, again one big line, one small line, again one big line, one small line. This is the representation of battery, where two or more cells are connected with each other. This is a symbol used for battery. Next is plug key or open switch. Plug key or switch. Let us see what is meant by open plug key and open switch. The current is not passing in the circuit. It is called as open circuit. To show that open circuit, the switch should be open. This is the representation of switch, which is open where the current is not passing. Closed switch. Next, we will see how to represent a closed switch. When switch is closed, the current will be passing through the circuit, and that type of circuit is called as closed circuit. How to represent the closed switch? This is called as closed switch. How to represent a conductor? A conductor is represented by a simple straight line, and where the arrow mark indicates the passing or the flow of electrons. Then in sometimes we may see that in our home also 2-3 wires are joined together. How to show the joining of the wires in a circuit? We can show it in this way. You can see here that 3 different wires are connected with each other at a single point. This is called wire joined together. Next, in this circuit we want to show that one wire is passing over the other wire without joining it. How to show that in a symbolic way? Wire passing or crossing O1. We can show it in this way. This is a wire and this wire is passing over the second wire. This is the symbol used for wire crossing over. Next, I told you that ammeter. It is a device which measures the strength of the electric current. How to show that ammeter is connected in the electric circuit? The symbol for ammeter is draw a circle. Inside it denote it as A, which represents that this is an ammeter. We saw that the potential difference is measured by voltmeter. How to represent the voltmeter in a circuit by a symbol? The symbol used for voltmeter is draw a circle, write V inside it, which represents it is a voltmeter. These symbols are very important. One mark questions can be asked for the symbols. So, please note down these symbols or please go through these symbols and see for cell what is a symbol, for battery what is a symbol, for open switch what is a symbol, for closed switch what is a symbol, conductor, likewise wire joined together, wire crossing over, ammeter and voltmeter. It is very important, which can be asked for 1 mark. Last time we saw what is electric current. Free flow of charges is called as electric current. The symbol for electric current is I, capital I. We also saw that the unit for electric current is ampere. We know how to find out the electric current. The formula used for finding out electric current is I is equal to charges divided by time, which is equal to Q by T. Similarly, we saw what is meant by potential difference. Work done to move unit charge from one point to another point in electric field is called potential difference. It is denoted by capital V and its SI unit is volt. We know how to find out potential difference. The formula used is W is equal to work done divided by charges, which is W by Q. Let us see that whether there is any relationship between I and V. A scientist called as Gregor Ohm tried to find out the relationship between electric current and potential difference. Potential difference is nothing but it is also called as voltage. So, let us try to understand the relationship between electric current and potential difference by performing an experiment on it and try to find out what is the relationship. To perform an experiment, Ohm's law used these connections. One by one I will explain what are the electrical components used by Ohm's law to know the relationship between electric current and potential difference. He used battery, where he used 2 volts battery, 1, 2, 3, 4. 4 batteries of 2 volts he used. Then he connected the positive end of the battery with the wire, which this is called as a resistor, whose current and potential difference is to be calculated and the relation between them is to be drawn. So the resistor is made up of nichrome wire. Nichrome means it is 80% of nickel is mixed with 20% of chromium. Nichrome wire is an alloy. Mixture of 80 and 20% is taken. Why nichrome wire was only chosen? Because it has high resistance. Resistance stability is there. High resistance stability means with temperature the resistance does not change. Almost it remains the same. So nichrome wire was used. Let us see how the nichrome wire is connected with voltmeter. The connection of voltmeter and a resistor will be always parallel to each other, which is connected to the ammeter. Already I told you what is meant by ammeter. A device used for measuring the strength of the current, which is connected with the switch. I told you what is meant by the switch, and which is connected to the negative of the battery. How did he start the experiment? He took the connection and he connected with the first battery, which is having 2 volts. Then he saw what was the volt in voltmeter and what was the current in ammeter. And to know that, he made a table calculating the volt and calculating the ampere whenever he increased the volt in the cell. And he got the following results. When the switch was opened, he saw that no current was passing through the circuit. In the voltmeter, the reading was 0 volt, and in the current, the reading was 0 ampere. That means when there is no potential difference, the current will not flow. That means potential difference is needed for the free flow of current. Then he took the 2 volt, and when he made the switch on, and when the wire was connected with 2 volt, we saw that in the voltmeter and in the ammeter there was a deflection. In the voltmeter it was 1.2 volt, and in ammeter it was 30 microampere, which we can convert it into ampere by dividing it by 100, which is equal to 0.03 ampere. So the first reading was 0.03 ampere. Then he connected the wire with one more cell. So it is 2 volt and this is also 2 volt. So what he did is he connected with the 4 volt, and he saw the deflection in voltmeter and in ammeter. He got the deflection in voltmeter as 3.6 volt and in ammeter as 100 microampere, which will be equal to 0.1 ampere. Then he connected with the third cell, which is also 2 volts. So totally it became 2 plus 2 plus 2, 6 volts. He saw the deflection in the voltmeter and in the ammeter. In voltmeter, the reading was 6 volt, and in ammeter, the reading was 180 microampere, which when divided by 100 becomes equal to 0.18. And at the last, he connected to the last battery, which was also 2 volt, means totally it was 8 volt current was passing. He saw the current and voltage in the voltmeter and ammeter. He found that the voltage was 8.4 and the current was 240 microampere, which will become equal to 0.24 ampere. Seeing the table, we can see that as the voltage increased, the current also increased. What does this shows? That the voltage and current are directly proportional to each other. To the experiment. These were the results what we got. Let us draw a table out of this. This is current, which is represented by I, SI unit is ampere, volt, which is potential difference, which is represented by V, measured in volts. And here we are going to see what is the relationship between voltage and current. Already I told you that as the current increases, the voltage also increases, or as voltage increases, the current also increases. So we can say that volt is directly proportional to the current, which means the ratio of volt and current or the ratio of potential difference and current will always be constant. That is what we are seeing in this table. When volt is 0 volt and current is 0 ampere, 0 by 0 is 0. When volt is 0.03, current is 1.2, 0.03 divided by 1.2 is equal to 0.025. When volt is 0.1 and current is 3.6, it is 0.027. When volt is 0.18, current is 6, it is 0.030. When volt is 0.24, current is 8.4, it is 0.028. Here you can see that almost V by I is always constant. This he showed or represented in form of a graph. Let us see how to represent these measures in the form of the graph. This is the x-axis on which the current is represented, and this is the y-axis on which voltage or potential difference is represented. Here we have to take a scale, and you have to be very careful while taking a scale. Here I have taken on x-axis 1 centimeter is equal to 2 volts, and on y-axis 1 centimeter is equal to 0.25 ampere. So this is the ampere and this is the voltage. Now let us see what happens. Now first reading is 0, 0. So I have marked over here 0 volt, 0 ampere. It is marked over here. You can see a dot mark over here. This I have represented 2 volt, 4 volt, 6 volt, 8 volt. I told you the cells I had showed. Each cell is having 2 volt. So that volt I have shown in the form of 1.2, 3.66 and 8.4 as in this table. So when 1.2 volt is shown, when 2 volt current is passed, when 1.2 volt is shown, the current is 0.03. So the measurement of current volt is 0.03. So that I have shown over here. So that is the graph over here. When 4 volt, that is 0.6 is there, it is 0.10. This is the point. When 6 is there, it is 0.20. When 8.4 is there, it is 0.24. This you can see. When all these dots which are represented over here, when I join it, I get a straight line graph which shows that the graph of voltage and current is always a straight line, which was proved by Ohms. Why? Because V by I is always constant. So this is the result regarding Ohm's law, and Ohm's then propounded his law by saying that at constant temperature, the temperature is constant over here, at constant temperature, the potential difference between any two terminals is always constant with the current flowing through it. This is what the Ohm's law, he propounded this law, and by this law we can say that V by I is always constant. Let us see what does the Ohm's law says. Ohm's law says that at constant temperature, the potential difference V across the ends of given metallic wire in an electric circuit is directly proportional to the current flowing through it. What does it mean? That the potential difference V is always directly proportional to the current, which can be shown mathematically. In this way. Let us say that the potential difference is represented by V and current is represented by I. It shows that the potential difference is directly proportional to current. It means as the potential difference increases, the current also increases. As the potential difference decreases, the current also decreases. So we can show that the potential difference, the ratio of the potential difference and current is always constant. This is what the Ohms proved, and this constant that was represented constant was represented by ohm as resistance, which is denoted by R. R means the resistance. So, the resistance of any wire depends upon its potential difference and current. This is what the ohms proved it. So, we can say that then a question arises. What is meant by resistance? So, let us see what is meant by resistance. Resistance means what? So, let us try to understand the meaning of resistance. What is meant by resistance? Now, I will give you an example. At home, your parents tells you to read. In the school also, the teachers tells you to read. So, you read whatever you want. But you feel one time that why always parents and teachers are telling me to read. So, you want to oppose that. That opposing factor is called as resistance. Here also what happens in the conductor, when electrons are moving freely, certain electrons are there which come in the way of these electrically charged particles. They try to stop them, they try to oppose the free flow, that we call it as resistance. So resistance is nothing but it is the property of the conductor. It is the property of the conductor to resist the flow of charges is called resistance. In other words, we can also say that obstruction for free flow of charges through the conductor is called resistance. So we can say, now see what is meant by resistance. It is nothing but it is the property present in the conductor. Any metallic wire, whether it is a copper or aluminium or silver, they have in them the charges will be flowing very freely. But sometimes these charges are resisted. Resisted means obstructed. The charges cannot flow very freely. And this is called as resistance, or in other words we can say obstruction for free flow of charges through the conductor is called resistance. And the resistance is denoted by capital R. Ohms denoted resistance as capital R. And the SI unit for resistance is named after the scientist. It is called as ohm, and it is also denoted by a symbol. This is the symbol used for denoting the resistance. So this is meant by resistance. So once again, what does the Ohm's law say, and how did he derive the physical quantity called as resistance with the help of Ohm's law? The Ohm's law says that at constant temperature, the temperature should not change. The potential difference across the ends of the given metallic wire, any metallic wire in an electric circuit, is directly proportional to the current flowing through it. That means when the potential difference increases, the current also increases. When potential difference decreases, the current also decreases. With the help of this law, Ohm was able to find out a new physical quantity which is called as resistance. And that V by I is equal to R is constant, that he named it as resistance. Then what is meant by this resistance? It is a property of a conductor to resist the flow of charges. It is present in the conductor. All the conductors have this property. The flow of the charges will be obstructed. So there will be no free flow of charges. Something is there which is obstructing, and the obstruction for free flow of charges through any conductor or through the conductor is called a resistance. And the resistance is given by capital R, and its SI unit is named after the scientist Ohm. So SI unit of resistance is Ohm. Let us study what is the meaning of 1 ohm. We know that ohm is the SI unit to measure resistance. What is meant by 1 ohm? 1 ohm is there in a particular conductor. What does it mean that? If the potential across the two ends of conductor is 1 volt, if the potential across the two ends of conductor is 1 volt and the current through it is 1 ampere, that means if the potential difference is 1 volt and the current passing through it is 1 ampere, then we can say that the resistance of that particular conductor is meant by 1 ohm. So if the potential across the two ends of conductor is 1 volt and current through it is 1 ampere, then the resistance is 1 ohm. This is the meaning of 1 ohm. We already saw that resistance, potential difference and current are interconnected with each other. We can represent the resistance by a formula V by I. What does it show? That the potential difference is directly proportional to the resistance and current is inversely proportional to the resistance. So we can say that V is directly proportional to the resistance, which means as the potential difference increases, the resistance also increases. As the potential difference decreases, the resistance also decreases. Current and resistance are inversely proportional to each other, which means if the current increases, the resistance decreases. If the current decreases, the resistance increases. This is what the relationship between potential difference and resistance, current and resistance. Let us see what is the meaning of 1 ohm. If the potential across the two ends of conductor is 1 volt and the current through it is 1 ampere, then the resistance is 1 ohm. This shows that if the potential difference in any conductor is 1 volt and the current will be 1 ampere, then we can say that the resistance of that particular conductor is 1 ohm. We can represent the resistance as V by I is equal to R, where V is directly proportional to R and resistance is inversely proportional to the current. What does it mean that if the resistance is doubled, then the current is half. So R varies as 1 by R. Resistance is doubled 2R. Then what will R become? R varies as 1 by 2I, means the current will become half. Similarly, we can say that if resistance is tripled 3 times, then 3R varies as I, then R is equal to 1/3 of the current. This is a relationship between resistance and current. Okay. What about the current and resistance? It is the same way. Current is inversely proportional to the resistance. So this we can say, if resistance is doubled, then the current is half. If resistance is tripled, then the current becomes 1/3 of the resistance. That is what here we can show. I told you last time that resistance and current are related to each other. How I explained you also previously. If resistance is doubled, the current is half. If resistance is tripled, the current becomes 1/3. Same way, if resistance is half and 1/3, the current also gets doubled and tripled. That means if resistance is half, the current gets doubled. If resistance is 1/3, the current gets tripled. We saw earlier the VI graph. VI graph means what? Potential difference and current graph. The graph of potential difference and current in nichrome wire is always a straight line. You have to remember, one question can be asked, what is the graph of VI in nichrome wire? It is always a straight line. Why? Because from the graph we can see that as the current increases through wire, the potential difference also increases linearly. Linearly means in a straight manner. So the graph of VI is always a straight line. This is also a second definition for Ohm's law. Ohm's law can be defined in this way also. We saw that resistance is very important in a conductor. So, on what factors does this resistance depend? The resistance depends upon these following factors. First factor is length of wire, which is denoted by small l. What does the length of wire means? It says that if the length of the wire increases, the resistance also increases. If the length of the wire decreases, the resistance also decreases, which shows that resistance and length of wire are directly proportional to each other. Why the length of wire increases and why the resistance increases? Because as the wire becomes longer and longer, the obstruction power also increases. If obstruction becomes more, the resistance also becomes more. That is why the length of the wire plays important role in forming the resistance. Second one is the material of the wire. Material means whether it is a copper wire or whether it is an aluminum wire or it is a gold wire. We know that all the metals have different valence electrons, that is the free electrons. The free electrons in some metal may be more, in some metal may be less. Depending upon these free electrons, even the resistance also depends. So resistance depends upon the material of wire. Third factor is thickness or cross section of wire, which is represented by A. That means if this is a wire, I will show you wire. This is called the cross section. This is a thin wire. This is called as the cross section. So in comparing these two, we can see that the cross section of this wire is less than the cross section of this wire. So how does the resistance depend upon it? Cross wire and resistance, that is cross section of a wire and resistance, are inversely proportional to each other. So R is inversely proportional to each other. What is inversely proportional means? As the thickness increases, the resistance becomes less. That means here you can see the area over here is wider. So the electrons will get more space to move. So there is no colliding of the electrons. That is why the resistance will be less. Here you can see the area of cross section is less. So more electrons will be colliding with each other, which we call it in other terms the obstruction. Opposing power will be more. So the resistance will be more. That means thin wire has more resistance and thick wire has less resistance. That is what the thickness or cross section of wire means. And the last factor is temperature of the wire. As the temperature of a wire increases, the resistance also increases. The temperature decreases, the resistance also decreases. Means resistance and temperature are directly proportional to each other. Why this change is there? When we increase the temperature, what happens is that the movement, the kinetic energy of the electrons increases. So the electron starts moving faster. When they start moving faster, they don't flow in a straight line, they get diverted. When they get diverted, they collide with each other and the obstruction becomes more. So the temperature rises, resistance is more. Temperature decreases, resistance is less. These are the four factors on which the resistance depends. Now let us see the relation between current, which is I, and resistance. What happens to that relation? These factors on which resistance depend, they also depend on, the relationship is with the current also. If current is inversely proportional to the thickness of wire. Thickness of wire means area of cross section. Okay. Thinner the wire, flow of charge is easy. That means current can easily pass through a thin wire rather than a thick wire. thin wire because the electrons are nearer to each other and the charges can easily pass from one electron to another electron. If the thickness becomes more, the distance also becomes more. So the passing of the charges from one electron to another electron takes time. So thinner the wire, flow of charge is easy. So current and thickness of wire is directly proportional to each other, which can be shown as I is directly proportional to A. Similarly, current can flow very easily if temperature of wire is less. Because if temperature of the wire increases, the kinetic energy of the electrons increases and these electrons may not flow in a straight line. They may collide with each other, so the flow of charges will become less. If temperature is less, the charges or the electrons will flow in a straight line. That means the current can pass very easily if temperature of wire is less. So this is how the relation between current and resistance is there. Similarly, we can say that length of wire and area of cross section of wire are interrelated with each other. That we can show it is. Already I explained the factors. As the length increases, the resistance also increases. So R is directly proportional to L. Let us keep it as equation number 1. We also saw that as the area of cross section increases, that is area of cross section and resistance are inversely proportional to each other, which we can show it that R is proportional to 1 by A. Let us take it as equation number 2. Let us write down equation 1 and equation 2 together. We can represent it as R is proportional to L by A. R is directly proportional and R is inversely proportional. In denominator, A has come means it is inversely proportional. So, we can get an equation for this. Last in 9th standard I explained to make an equation, proportion sign should be converted to equal. When proportion sign is to be converted to equal, you have to add one constant. So here rho is a constant proportionality which is added. So R is equal to rho into L by A. Rho is a constant proportionality for electric resistivity. Electric resistivity is rho. And the SI unit for electric resistivity, that rho is ohm meter. So this is a relationship where if length of the wire is given, cross section of the area of cross section of wire is given, then rho value is given, then we can find out what is resistance. The value of rho is given by, it has a certain fixed value which we can get it through calculation, and the value of rho will remain constant. By substituting a value of that rho, we can get the value of resistance. Here I have shown the resistivity of materials. One side materials and another side resistivity is there. Usually we say that metals and alloys have resistivity from 10 to the power of minus 8 ohm meter to 10 to the power of minus 6 ohm meter. That means the resistivity is very less. That is why metals and certain alloys are called as good conductor of electricity. Good conductors of electricity depends upon the resistivity. Less the resistivity, the conductivity is more. More the resistivity, the conductivity is less. Insulators like rubber and glass, you can observe that its resistivity is more. It is from 10 to the 12 ohm meter to 10 to the power of 17 ohm meter. Resistivity is more. So they are bad conductors of electricity, or we can call them as insulators. Now a question arises. Only copper and aluminium in the metals are used as conductors. Aluminium is used for transmitting in transmission lines from where the electricity is produced to the cities, and in our houses we use copper as a conductor. Why these two metals are only used? Because you can see that its resistivity is less. So they are good conductors of electricity. That is why copper and aluminium are used as conductors. Let us see the next one is tungsten. Comparing to these two metals, tungsten is having high resistivity. So we don't use tungsten as conductor, but we use tungsten in the electric bulb where it gives the heating effect and then makes the bulb to glow. So tungsten wires are used for electrical heating devices because its resistivity is more the resistivity, more the heat is produced. Already I told you previously, friction charges are there. It gets rubbed against each other due to which the heat is produced. You can also get one example for that. When you switch on a mixer or grinder for a long time, when you touch it, it becomes hot. You can feel the heat of that. Why? Because due to the resistance of the conductor which makes the device to be hot. That is why tungsten is used as electrical devices where heating effect is needed. Let us see the relationship between resistivity and conductivity. Resistivity, I already told that the obstruction offered by the charges to disturb the flow of electric current is called resistivity. Conductivity means where the charges can flow freely is called as the conductivity. What is the relationship between these two? How they are related together? We say that the resistivity of material decides the conductivity of material. Means we know that each metal or alloy have valence electrons, different valence electrons. Depending upon these valence electrons, the resistivity and conductivity also depends. More the valence electrons, more the resistivity, less the valence electrons, less the resistivity. How they are connected with each other. If the resistivity becomes less, the conductivity will be more, means it will be called as a good conductor. Even the temperature also depends on resistivity and conductivity. As the temperature increases, the resistivity increases. I told you, because when temperature increases, the kinetic energy of the electrons increases. They start to move randomly. When they start to move randomly, the collision will be there. Due to the collision, the flow of charges can't flow in a proper way. So the temperature increases, resistivity increases and conductivity increases. This is how the resistivity and conductivity are dependent upon each other. So you have to keep in mind, a good conductor of electricity means where the resistance is less. A bad conductor of electricity means where the resistance is more. So that is how the resistivity and conductivity depend upon each other.